What if I told you that the secret to building the Great Pyramid wasn't alien intervention, but a lost ramp system, recently uncovered, that makes sense of thousands of tons of stone moved with tools from 4,500 years ago? The structures found aren't fantasy. They may rewrite what we thought impossible. Let's dig into what archaeologists actually discovered, and how Egypt's greatest builders really did it. In 2018, a team working at an ancient alabaster quarry at Hatnub uncovered a ramp system used around the same time the Great Pyramid at Giza was built. This steep ramp was carved directly into the rock, not a gentle slope, but significantly steeper than what previous ramp theories assumed possible. On either side of the ramp were post holes, signs that workers planted wooden posts. Researchers argue these posts likely supported ropes, enabling a pulley-like system. With people pulling from both sides, from below and above, they could haul heavy blocks more efficiently than simply dragging sledges on flat ground. A recent computational analysis tested what's called the Integrated Edge Ramp, or IER, model. This model imagines a multi-ramp strategy. As the pyramid rose, ramps spiraled or wrapped along the edges, with carefully calculated geometry, finite element stress testing, and logistical throughput measured along a detailed timescale. Under this model, including quarrying, river transport, and seasonal pauses, building the pyramid could take around 20 to 27 years. Beyond ramps, a provocative new theory proposes that the Egyptians may have harnessed water power for construction, especially in early pyramids. According to a study of the Step Pyramid of Giza at Saqqara, nearby water channels, seasonal streams, and specially engineered dams may have fed a hydraulic lift system. Water could have floated or lifted heavy blocks internally, reducing reliance on manpower alone. If true, this doesn't replace ramp theories, it complements them. Early pyramids may have relied more on hydraulics, while larger 4,500-year-old structures combined multiple methods depending on available resources, workforce, terrain, and water supply. You know, the lack of records, no construction plans, no user manuals, no inscriptions describing step-by-step building methods, has long fueled speculation. But modern archaeologists believe that was intentional. The pyramids were monuments, symbols of divine power and eternity. Detailing how they were built might have, well, undermined that mystique. So, instead of plans, what remains are quarries, ramps, tools, worker villages near the plateau. And those are exactly the clues researchers now use. By combining archaeological remains, modern engineering models, and geological data, we can test hypotheses and reconstruct a plausible history grounded in evidence. At Hatnub Quarry, the carved ramp and post hole system is, honestly, concrete evidence that Egyptians could haul heavy alabaster blocks using techniques way more sophisticated than just a straight drag and pull. The computational IER model shows that building a pyramid over 2 decades was logistically possible, even with the heavy stress and weight of blocks. And that really helps dispel ideas that pyramid construction somehow defied normal human capacity. The study on the Step Pyramid reveals that, on early monuments, Egyptians experimented with hydraulics, possibly using water pressure to raise stones, a sort of forgotten engineering tradition that may have influenced later techniques. These examples show variation. Different materials like alabaster, limestone, granite, different locations such as quarry versus pyramid site, and likely different techniques depending on those variables. Because understanding how the pyramids were built isn't just a matter of satisfying curiosity. It actually tells us about human organization, engineering, resource management, and society at a time when, honestly, modern infrastructure didn't exist. For historians and geographers, it shows how ancient peoples leveraged environment, ingenuity, and labor efficiently. For modern engineers, it's a case study of resourceful design under constraints. For survival-minded thinkers, or anyone interested in how societies build lasting monuments, it's a lesson. You don't need rockets or steel to build something monumental, just planning, coordination, and clever use of physics. For cultural heritage and archaeology, it provides a path. Rather than mythologizing, we can use evidence-based research, modeling, experiments, quarry surveys to reconstruct ancient methods. That keeps us honest, grounded, and respectful of what humans really achieved. Because the pyramids aren't miracles, they are human achievements, built by skilled workers using understanding of physics, materials, and logistics. The evolving evidence, ramps, hydraulics, computation, shows how human ingenuity can meet monumental challenges. If you watch documentaries or read books, demand evidence. Appreciate that what's unknown doesn't require fantasy. Use what we now know to re-evaluate older assumptions. These pyramids teach us, even in ancient times, people innovated, they adapted, they planned, and they built. If you want to dig deeper into ancient engineering, next time check out how the temples, obelisks, and massive statues were carved, transported, and erected. Real stories of human effort, not miracles. If this deep dive into how Egyptians really built the pyramids offered you new insight, hit like, subscribe, and check out my next video exploring the engineering behind Egypt's ancient obelisks.